In this video, I will discuss the iterative greedy approach to solve the activity selection problem. Now, the iterative greedy approach to solve the activity selection problem is the simple yet the most effective solution to the activity selection problem. Once again, say we have an activity selection problem that looks like this. Here's our resource, and then we have 5 different activities fighting for the resource. S represents the start time of the activities. F is the list of our finish times. We have n equals to 5 as the total number of activities. Once again, the trick in all the greedy approaches is to pick the activity that finishes first. So remember that the activities are sorted by their finish times, and the idea is to pick the activity that finishes first. So what we would like to do is implement this algorithm, greedy activity selector, that takes our list of start times and finish times as input. And what this is expected to return is this set A, the maximum size mutually compatible activities, which is our optimal solution. Now let's initialize n to the total number of activities. We can do s dot length or f dot length. And then because we know that the activities are sorted by the finish time, and that by principle, the first activity is obviously the activity that will be a part of our solution because they are sorted by the finish time. We will pick this activity and put it into the solution. So our solution includes first activity A1. Now remember, activity A1 is the first activity based on its finish time. So obviously this becomes the part of the optimal solution. Now what we would like to do is scan through all the remaining activities, say for example here A2, A3, A4, A5, and then we try to find the next activity by checking their start times. Now we know that the activities are already sorted by their finish times. So all we have to do is throw away the activities that overlap or are incompatible with our current activity. In other words, if I have A1 as a part of my optimal solution, all I have to do now is go by the order of this finish time and then keep throwing all the activities that are incompatible with A1. As long as I throw all the activities that are incompatible with A1, the next activity that's compatible with A1 will be a part of the optimal solution because they're already sorted by the finish time. Now, to represent our most recent activity added to the optimal solution, I'm going to use this index k to represent this because A1 is the most recent activity added to the optimal solution. I will use this index k to represent most recently added activity to the solution. So I'm going to scan all the activities starting from the next activity to the nth activity and check if the start time of this activity m is more than or equal to the finish time of our current activity. So here A2's start time is not more than or equal to the finish time of A1. So we do not want this activity. This is incompatible. If this happens, then we will keep looping through. Otherwise, if we find an activity whose start time is more than or equal to the finish time of our previous activity, so this is A and let's say this is M, then we will add this to the part of our optimal solution. So if this happens, then we do A equals A union, we add now AM to the solution. And once we do this, we set K equals M so that now our current solution M becomes the previous solution, or in other words, now we mark this activity A3 as our K so that we start looking at the finish time of A3 instead of A1. And then finally, once all of this is done, once M runs from 2 to all the way through N, we simply return A, which is a set of the optimal activities. Now let me trace this algorithm one more time to further clarify the flow. So we have S and F as input. We have N equals to 5. Our optimal solution includes A1, and then we have K equals 1. So we start from M equals 2 through N. If S2, so we check is S2, that is S for activity number 2, more than or equals to finish time for activity number 1. So start time of the second activity is 1 and finish time of the first activity is 2. So a start time of second activity is not more than finish time of first activity, or is not even equal. So this is incompatible So that means this if-else statement executes to false. That means we continue through the next item. We have m equals 3 now. Then we check, is the start time of this activity 3 more than or equals to the finish time of activity 1? In other words, we check if the start time of activity 3, which is 3, more than or equals to the finish time of A1. This is true. So now we add A3 to the solution. So our A now initially had A1, now it has A3 as well. And then we set K equals M. Next, we increase M to 4. So we check, is start time of activity number 4 more than or equals to finish time? Now K is already 3, finish time of activity number 3. So we are checking, is the start time of activity number 4 greater than or equals to the finish time of activity number 3? This is true. So this means we add A4 to the solution. So A4 becomes a part of the optimal solution. And then we set K equals to 4. So then we have K equals to 4. We have M equals to 5 now. We check, is S5, start time of activity number 5, more than or equals to the finish time of activity number 4? So start time of activity number 5 is 5 and finish time of activity number 4 is 6. So S5 is not more than F4, and so we do not run this part, and then we end the for loop and we finally return A1, A3, A4, this set as our optimal solution. Now, because we scan all the activities once, the running time of this algorithm is big theta of n, where n is the number of activities. Now, remember, this running time assumes that the activities are sorted by their finish time. If they are not sorted by their finish time, then the running time of this algorithm is big theta of n plus the time to sort, time to sort. Usually, sorting can take anywhere from n square to n log n time, depending upon what kind of sorting technique is used. So this running time could actually be only the lower bound if the activities are not sorted already by the finish time.